There we go. And then go to the green and do full entire screen. But as soon as that comes up in that, minimize. There we go. Okay. And I'll test it and let you know if there's anything coming up. So I'm going to let Ben go ahead and introduce himself. He needs no introduction. He's awesome. But I'll let him introduce himself and go through his slides, what he's going to be talking about.
Okay. So my name is Ben Taylor. I'm the chief data scientist for HireView. We're a local digital interviewing company here in South Jordan. And you're probably wondering, why do you guys need data scientists? Because you just do mobile app stuff, you do interviewing. Justin here, he's also with HireView. So we do have machine learning that we run on interviews. So we analyze voice to text. So everything the candidate said during the interview, we analyze facial features. So we're talking about action units on the face. So think about micro expressions. And then we also look at speech patterns, and we bring all of that together into models, and we predict which candidates are more likely to have interviewed better than other candidates. And so some of our largest clients that have thousands or even tens of thousands of interviews, they can now get to the good people quickly. And for the people that kind of exhaust you emotionally during the interview process, they're less likely to come up through that list. So yeah, that's been really fun. We're kind of first in that space with HR because it's a pretty aggressive play, especially for an HR company. So we've had that product out for a year. We have customers that are using it, and we continually add new feature sets to that. So if anyone has any questions about how we do the prediction or how we lessons learned, I'd be happy to talk more about that later. So for this competition, it's kind of a new one for Utah, where we're going to be predicting its image classification. And it's a fun data set. This is not a data set that you can just go find online, because this is a data set that I made from some NASA data that was available, but it wasn't formatted in the type of format you would want it to be for a competition. So the original format, they had these massive images, and then within one image, they'd have like 30 volcano locations within one image. And for you to do classification, you actually have to segment these out into standard sizes. And you need to have images that you know have volcanoes and images that don't. And it's actually really fun, because after you build your predictive model, you can do some really cool eye candy, where you take a high resolution image of Mars, and then you scan your model across that image, and you can come up with these heat maps where you think the volcanoes are. So that's kind of the use case, where using some simple machine learning now, they can scan a lot more data than they would have been able to previously, and find different things in the data set. So the things that you learn going through this process will be general, so you can apply those to handwritten digit classification or other image classification needs that you guys might be interested in. And just kind of a refresher, one of the last things we were talking about was how to handle text. So for people that aren't familiar with text, if I have something like a resume or a cover letter, and this is true with all data science problems, you have to get it into a structured format. So in the end, I need to have one row of numbers for my observation. So if I have resumes and you tell me to do a resume model, I need to figure out how to take a whole resume and digest it down into a single row of numbers. And so with text modeling, what you do is so with text, you can do bag of words or bigrams, and you can get these massive feature sets. Like we've had some that go over 1 million. So I have over 1 million columns in my model, and they represent single words or word pairs. For a resume, you could be a little bit more specific, where you actually looked at GPA. GPA needs to go in this column. School needs to go in this column. Hobby needs to go in this column. And so that's your attempt to structure the data. And the algorithms can't use the data set until it's 100% numeric. So with text models, and when you're dealing with categorical models, in the end, you need to tokenize it and get it into some numeric format, because that's what your regressions, your random forest, really, when you kind of get down to the math, that's what they need. Some libraries may handle that for you on the front end, where you can throw in a label that's not numeric, but on the back end, that's what they're doing. They're gonna take something like Yale, and they're going to assign a number to it to keep track of it. So for this data competition, there's a 240 meg tar file that Nick has posted online. You can download it, and it's pretty large. It has over 40,000 images, and I've been downloading it in the background. Let's see. Okay, so it actually finished. So there's sorry, it's hard to, I'm gonna zoom in as much as I can. So this is kind of cool. You can do a curl command on this tar file, and then you pipe that through, and it'll actually uncompress it while it's downloading in real time. That's just kind of a geek thing. You don't need to do that. I could just do wget download file, or I could manually download it. But I noticed that, and I thought, oh, that's really cool. That is uncompressing it while it brings it down. So if you do this, you're going to see these two folders. And so you're going to have Volcanoes. So these are images that are not volcanoes. So if I go in there and take a look at that, so apologize. You guys see that okay? I'm in there, got time. And there it is. It's this tiny, tiny. So all the images are standardized to 90 by 90 pixels. So there's not a volcano in this image. But if I go pick, and I'll show you how many files we have in there. Let's see. There should be 40,000 files in here. When you get that many files, sometimes it's a little weird when you're, like sometimes you'll get the argument list too long and stuff like that. I'll jump over to the Python so you can actually see how we make use of this data. But I wanted to show you what a volcano actually looks like. So that's a volcano. Don't be disappointed. So that little dot in the center.
It's huge.
Yeah, it might not look like much, but NASA scientists, they've identified that as a volcano, and we want to help them find that sooner. And
how does that differ from a crater?
well, so I don't know if the pixel values, if there's any information there about height, but
That's why I was curious.
yeah, there could be some height. Yeah, there could be some height information, but you'll see with some of these other photos, it does get a little bit more complicated because you'll still have peaks and mountains, but they're not volcanoes. And it's kind of hard to see that with the black and white image. And so I'll actually show you. So it's the same image. I just added the color map. The volcano is pretty obvious. You've got this bright red point. Here it's white. And if I scroll down, you can see like these are still these are ridges and peaks, but there's no volcanoes in this image. So I'm going to show you how easy it is to do. So something that we like to do, the last thing we want to do is have anyone get frustrated or kind of sit there wondering how am I going to set this up. So we want to give you guys a Python script to kind of kick it off where you can at least get a solution. And I'll tell you what's going on. So you had to download the data set locally. And then I'm going to import this library called glob, which I like if you're looking through lots of files. And then to read the images, I'm pulling this. There's lots of libraries that'll do this, but the one I'm using is from SciPy, so I'm going to import that. And then with most data science stuff, you're always going to import NumPy. Like you end up using it. It's almost impossible not to use. And so kind of going back to the beginning, if I have an image, I need to figure out how to fit it into a row format. And so it's a lot more trivial than, with most data science applications, when you actually figure out what you're doing, you're usually underwhelmed. Like it's not, all we do with the image is if it's color, we flatten it, so it's black and white. We have a matrix, that's a problem, and so we unravel the matrix. So you can think of, you flatten it and you smash it, and so the 91 by 91 is not now 8,000 values long, and then you're consistent. So you're consistent with where those pixels are falling in place, and now you've got your row and you can build out your matrix. So I have this little function here called image smash. So the IM read, it's going to read the file name, flatten equals true, that's gonna, if a color image came in, I don't care. I'm going to make it a grayscale image. And then this NumPy command, NumPy ravel, that's really nice because it'll just unravel your data. So if you have a matrix that's 2D or 3D, it'll just take that and unravel it into a vector. So I've got this image, and now I'm calling, I want to get a list of all the file names that I just downloaded into these folders. So I'll call these for both of those folders. And then for this next block, all this is doing is it's going through file by file, it's unraveling it, and then it's inserting it into a matrix. So I've initialized this matrix. I've said I need a matrix. It's going to be however many files I have. It's going to be 40,000 files long. And then it's going to be whatever that first image is for length. Because I don't know. Actually, we'll do some live coding right here so you can actually see. So if I come here, because I don't know how long it's supposed to be. So if I just come here, and what I'm doing is I'm pulling the first file. So it's 8,281 values. So that's what happened when I smashed that file down. And I'll just do one more value so you can actually see. So if I just read that image in, so let's see what the image looks like. So okay, so this is the image name. If I read it in, I can see it's 91 by 91. So I've got a square. Those are my pixel values. I can even preview them if I cared to. Let's just take a look at what these look like. So I've got, I'm just going to look at the upper corner, 10 pixels. So this is an image. So an image will be that numbers from 0 to 255. And if it's color image, you'll have red, green, blue. You have 3 different matrices. So I've got that, and I've smashed it into this vector. And so this function down here is just going to loop through these files, and something that you never want to build this dynamically in memory, because it'll be really slow because you're essentially copying the object over and over. So I always initialize. So I'm calling this NP0s, where I initialize this huge matrix, and then I'm going to go down and I'm going to fill the rows. And I do that with a no. Python has this cool thing called, if you have matrices, you can do a vertical stack or a horizontal stack. And I can have as many matrices as I want. So if I had a bunch of matrices and I wanted to kind of bring them together, cap them together. And then now that we've done that, we have to assign a label. So the label would be volcanoes, I need a 1, and no volcanoes, I need a 0. So to do that, all I did was, I just did that. So I'm just saying, when I'm reading in the files for volcanoes, I know how many files I have. I'm going to say those are 1s. And then when I do that again for the no volcanoes, I'm going to say they're 0s. I bring it together. And in the end, we have our X and Y. So we've got X and Y. We know exactly what to do with the numeric X and Y. And when I was doing this toy example, I just had a small subset, so it actually run in real time. So I've got 14 images. But when you actually run this, it'll run for probably 20 minutes. And it's not going to take up a ton of memory. It's just going through and hitting your disk and pulling those images in. That'll take a while. And when you run it, you're going to get 40,000. Your matrix will be 40,000 long. So now that we have that in memory, you can really use any machine learning algorithm that you want. There's certain algorithms I'd recommend. Like you could use some type of regression, like least squares regression, logistic regression. You could use a Bayesian method. But the thing that you'll see is you won't be very competitive compared to people that use what we call ensemble methods, like random forest and deep learning. For this particular data set, they're going to do very well. And the other thing that's neat about this data set, when you're dealing with text and categorical, a lot of times those are sparse data sets, where this is extremely dense. Like when you talk about feature reduction, you're probably not going to do any feature reduction on this. And if you want to talk about like efficiency gains in memory, you're kind of stuck. Where with the text model, when I talk about I've got 1 million columns, I can actually say that as a sparse object. It's pretty light for my memory. And yeah, so for this example, this shows you how I would run a random forest. Oh, so the other thing that you want to do is you want to get a good sense of how well you're doing. And so you can do there's a nice library here in Python called train test split. So I can tell it, I need you to split out 90% of the data and hold 10, so I'm not cheating, and then I'll build a model and I'll test on the 10. So that'll do that for me, and it'll actually split it out. So I have 2 different matrices now, and then I've got 2 different label sets. So I can train using this random forest. So this is a pretty light random forest. I only have 10 estimators. And I always like to seed the random state, which is a good idea to do because you always want your outputs to be deterministic, where if I run this code again, it's going to be the same number. The reason that's nice to do is if you're consulting or you're talking to your boss and you run the model and you get a really good score, let's say I run this and I'm getting like an 80%, and that's great. And then I run it again in front of my boss or in front of the client, it's 75%, but I promised them 80%. So it's really smart to always, anytime there's a random number in there, I always like to make sure I seed that, seed my random state. So I also do it with the validation split. I do it with random forest. Okay, so I trained a random forest model, and then with accuracy, so I was doing this morning. This is actually on the big data set. So I'm going to show you what some problems are with accuracy. So if I just tested accuracy, I'm getting like 97% accuracy, but that's misleading because I have such a huge imbalance in the labels. So I only have a few, less than 10% of my observations are volcanoes, and then the rest are not volcanoes. And so if I say I've got 90% accuracy, someone who's not familiar with machine learning or they're more naive, they'd say that sounds great, but that's actually really bad. I could do, and it's really bad because it's not telling the whole story, because what you really care is how well are you doing on the volcano classification. I don't care, because I could have a model that said nothing's a volcano. It'll always give me a 0 and I'd have 90% accuracy. So that kind of shows you why that would be so silly to think 90% is a good number. You kind of have to look at the context of the problem. And so for this particular competition, we won't be scoring you on accuracy. When you can upload your predictions, but we're going to be scoring you on something called an AUC score. And this is a lot more accurate. So this really tells the story. So if I do a prediction, I can't remember what model. I think I did a pretty simple model here. This might even be a regression, but I'm only getting a 52 for my AUC score. And a 50 is random. So I'm doing slightly better than random. But using some of the better models like random forest, I'm getting up around 75. And then something I want to call out, normally when we do a model, how many people here are familiar with sklearn's model? How many people here have used sklearn? So a few people, 1 or 2 people. Okay, so I'm going to actually show you. So if I go and train a model, so I don't have time to train one. Let's see. Okay, yeah, I'll zoom in. So this is actually a model that I trained, and you guys will have the source code for this. This model took me 30 minutes to train. That's pretty serious. But once it's trained, I have this object, and this object can be called. I can pass things through and call predictions. So I can come here, and I can do something. They have something built in called score. So I can come here. I can give it my test set. So I'm giving it my test set to see how well I did. And yeah, that's actually, it's a really bad score on my test set. So, but the thing I wanted to show you guys is normally if I'm going to predict something new, I do .predict and I bring in the test set. And this would give me all of my predictions. So you could call this Y predict. And we could take a look at this. We could take a look at what we did. So that, and these will be really fast. Once we train a model, we can evaluate it quickly. And so if I look at this, I have a vector. I'll just print it first. So predict. Oh, okay. So this is a little bit more complicated than I wanted to get. So you'll see these numbers are not, these are not 1s and 0s like you would expect because I'm doing it. I should be assigning 1s and 0s because I'm saying there's a volcano here, there's not. So you can think of these as what my confidence is that there's a volcano there. So you can see some of these numbers are small, some are large, like 25% confidence. I can even see what my max is here. Let's see if we get anything bigger than 25%. But 39%, that was my highest. And this is not a true confidence, but these numbers will be from 0 to 1. And so if that's the image that is most likely to be a volcano, but I'm not actually committing to that. I'm just committing to an accuracy. Sorry, I'm kind of rambling, but.
Where's the accuracy coming from? Is that just built into the library that it predicts that, or is that something you're writing into it?
So typically when you're using classifiers, let's see if I can do one, because this is actually coming from a true gradient boosted regression. So this is coming from like least squares regression, where it will return a number from 0 to 1. But let's try to think if I can get, I can get something to return quickly. So I'm going to run, let's see if I can grab, random forest will take too long. Or no, I'll do random forest on a small set. So,
I mean, if I'm hearing you right, it's like part of this whole statistical method. It's not like you're not writing a separate function to predict the accuracy, or is it?
No, it's actually built into the class, and that's what I wanted to show you. And I guess here I've got a random forest, so I can show you. This model should be good to go. Let's see what it is. But yeah, logistic regression. So whenever you have a classifier in sklearn, I can do .predict, where it would return a 0 or 1. It's funny. But the thing I want to call out, there's a .predict log prob A. This is going to give me a probability. So it's not going to give me a 0 or 1. It's going to give me the log probability. And if I throw that into the AUC score, I'm going to get a better number. And that's what I show you right here. So here, if I just throw in the straight prediction, which would be a 0 or 1, I only get an AUC score of 52. But if I actually throw in this predict log prob, I get a 75. And the reason I get a 75 is because rather than me just committing to these are the 10 where I get full credit, no credit, I'm coming in with a continuous number where some things I'm really confident and other things I have medium confidence. So you're getting a little bit more credit for how well you did. And that's why I'm getting a higher score. And then, yeah, so this is the number that you'll be graded on. So a perfect number would be a 1. I'll be really impressed if anyone gets above 0.9. I think that will be unlikely, but maybe I'll eat my words and be impressed. So I think, let's see, I want to make sure I didn't miss anything. Okay, so the main thing I wanted you guys to take away from this is to not be overwhelmed with, because the hardest thing for you to do is to build those matrices, to build the X matrix and the Y and that Y vector. All of that code is right here. You can run it, and you end up with your X and Y matrix. And then here's an example in sklearn on running a random forest. But the great thing about sklearn, you can change this model object to be anything you want. So if you Google sklearn how to do logistic regression, how to do deep learning, you can plug in other models right here and get a different output. And so for people that do well, they'll try lots of different model types. And some people will even generate new features for this image set, which you can do that by creating more observations. Like with the volcanoes, you can actually rotate the images to kind of like boost your observation set. I don't know how much that'll help you, but in some competitions that will help you. So if you just mirror your images on X and Y, you can build out a bigger data set than the people you're competing against, and your model could be more robust. So that could be another thing that some people do, but some people could win without doing it. And the other thing that I wanted to show you, just to wrap up, so that exact same problem. So David Gonzalez and I, we've been working really hard for the last couple of months on coming up with these powerful Python libraries to do all of this for you. So you don't have to think about what's this data set look like, what am I going to do with it. And so this is an example where if I import my libraries, I can solve this with 4 lines of code, and that includes the data structuring and the prediction. And it's not just doing one model. Like this is going through like a whole array, testing everything, and then finalizing on the model set. And one of the exciting things about this is we took a data set from Microsoft for sentiment. If you guys don't know what sentiment is, it's the standard problem is Twitter. I have so with this data set, I have 160,000 tweets. Some of them are good, some of them are bad. And just using our method, we beat the Microsoft example. And this is their data set on their Twitter example. So we're pretty excited about that. But yeah, does anyone have any questions about the general problem, how you structure it, and what you're actually doing, or how it's being scored? So we do have a test set, and I didn't think about this when I uploaded it. I think it makes sense for me to just provide an unknown folder, and then that would be your test set. So when you pull it down, rather than having yes and no, you'll have yes, no, unknown, and then you would have to build a matrix from the unknown, and you throw it through your model, and that's what you'll be scored on. Will be the vector of values that you upload, and that will decide who wins.
How many times can we submit a day?
So we can do, I think we're a little bit more cautious about that. So I think once per day, like the thing we don't really want to encourage is we don't want people to think they'll do better by submitting more and more submissions. We want people to do better because they're doing more cross-validation or they're, so
And you'll actually be scored on your final submission
okay,
rather than just your best submission.
yeah.
So you have to actually pay attention. You can't create an automated script and put your own best and now have no idea what actually.
And when we've done it in the past, we only reveal your performance on like 30% of the true holdout set.
Yeah.
And then the other concern too, these are images. And so if somebody was unethical, they could manually go through 3,000 images. And
I thought about Mechanical Turk.
yeah, they could throw it out to Mechanical Turk and say, this is what a volcano looks like. There's 2 different ways to approach that. So one way, whoever wins, like for people that are in the top 10, we have them validate their code or send code. The other thing we could do is I would actually randomize the pixels on the images. And then if you looked at an image, it looks like noise, but it's consistently in the same place. And then it would be physically impossible for a human to know what a volcano would look like. And you can't reverse that. So that'd be a possible option if the community wanted it. The easiest thing to do is just upload the unknown folder, and we'll just hope people play fair, and then we can catch people that don't by validating their code.
And we do have well over 1,000 and potentially hundreds of thousands of people that will hear about it. So we won't be able to easily poll the community. But if somewhere along the way we start feeling like there are people out there that are cheating, things along those lines, then we'll actually announce at that time, okay, we need to change this so that it's a little bit more difficult.
Yeah. So to change it, your code would not change at all. We would just randomize the pixels and you do a new download, and that's bulletproof. You can't fake that. So, but it would do just as well. So with these ensemble methods, they'd figure out that these are the pixels in relationship to these pixels that matter, and so it's not going to hurt your performance, but will discourage cheating. Does anyone have any other questions on prediction?
Well, this is just more of like a housekeeping question. I'm a little confused. I know that, and forgive me, Nick, because I haven't sat down and read everything on the website for global data competition, but I know there's this like global or climate change related global data competition, but then you're talking about scoring this. So is this a separate competition that's local?
Well, maybe, do you want to answer that, Nick?
No, this is done on a global scale as well. People will compete on this. And even though we are talking about climate change, if you do read on the website, we actually say, look, we're trying to get out a climate change specific section for this as well that you can use. The problem with climate change, there's multiple problems. One is that it's climate change. There's so many other factors, so many other things that could go into what you're trying to look at on your model, so that you could be way off because we had a wetter than usual May, wettest in US history, right?
Yeah.
Now it changes your data set and makes what you created originally completely inaccurate. So this data set allows us to go around the world, also prevents us from having data that anybody can find.
No, that's very, it's interesting, yeah. I guess I got confused because on Saturday night, I had to leave for part of that. There was a guy showing all these different government data sets, and I thought those were part of the competition.
Yeah, so they have their own separate competition where there's 1,400 data sets on the state open data portal and then a bunch on Salt Lake City data portal. Then you can create a company out of
Okay.
and win a bunch of money by creating a company, an app, or
Okay, so
something else.
that's not the data set at all for it, but this is cool, but thank you.
So Nick, maybe just to bring up too, the phase 1, phase 2 sort of thing about the global
Yeah.
data competition.
So this
Is phase 1.
Yeah.
So we are hoping to get people competing here, talking about it, using this, competing, and then they're ranked, those scores. When we talked about the points in the global data competition, you get points based on how you are ranked in this.
Okay.
And that's how you generate some of the points for the overall of what you're gonna get for the global data competition. Phase 1 and phase 2. So this is, I don't wanna call it a warm-up or anything, but in other words, it's another way to get points related to the competition. So the competition is much more than just getting climate data and doing that part, it's also this.
Now, this one piece is worth 900 points for whoever wins. That's a third of the points overall. The other pieces will be broken down into dozen, more than a dozen different point systems that you can score points in. And so we actually feel like this type of prediction and everything else is a huge portion of what makes a good data scientist, a good big data engineer. But it's only a third of what you're going to do. There's a whole bunch of other things that relate. We're not going to make people do a bunch of operations stuff when they have to figure out how to worry about chatter on a database or whatever else. Unless they have to do that.
Well, you'll definitely want to jump into this if you intend to do the whole competition, because like Nick said, it's worth a lot of points.
Yeah.
Your ranking in here will give you points regardless of what that ranking is. So in other words, being ranked is important. Being one, of course, is the best, but
Right.
Something inside there, that's where you're going to get points based off of that.
Cool, thanks for clearing all that.
And just to clarify, you're gonna put up one more data set in the unknowns, right?
Yeah, so I'll add an unknown folder to this. I'll do it to the same data set, and then Nick will send out an announcement. So you don't need a new link. The same link will give you an unknowns folder, and that's what you'll be scored against. And once I have that, I'll have a notebook that'll do the full flow. So you'll get, assuming that you pulled down the files locally, I know what the folder names are. It'll go through there, generate the 2 matrices, train one on the model, test one on the other, and then write a CSV output that can be uploaded. So you'll see what that looks like.
And then we're saying that's a daily upload that you can do if you so choose. But your last one is the one that counts.
Yeah.
When did we intend to close again?
So we're leaving it open a little bit because there's a few countries that are really lagging behind and asking for extra time. But we're hoping to be the first week of July, maybe the second week of July. And then you go into phase 2. We may actually have those two overlap a little bit so that if you kind of finished up, you don't have to sit there and wait to the last minute to submit again, right?
Right.
We also, or also keep in mind that you can compete as an individual or a team or an organization. So we as Big Data Utah could actually compete together, and we can use a lot of people that are the experts out there and help teach each other, right? But we could also work as anyway along that scale. Also, when you fill out the registration form, you can fill out as each of those as well and be able to compete as an individual, a team, or an organization.
Oh, okay, that's cool.
So somebody posted on the list that they were looking for a team, because whoever that was, yeah, now?
I don't remember seeing one.
That was a guy named Mando, and I believe he was from the United Kingdom. So I'll look into that and double check. But easy to look at. So that's enough with the kids.
They want to compete, that's why.
So does this help everyone having the code example? Once that unknown is up, they can download a full code example and start modifying it.
Yeah, the point here is to take exactly what you've done, but then start putting in your own modifications to make the model better. Whatever
Yeah.
this is gonna spit out, obviously, is not your final that you wanna end up with. You wanna change and modify this and go forward.
Yeah, so this will give you a 75. I was able to go over 80 playing around, and maybe someone will go over 90, but that'd be pretty good.
Did you go for 80 without changing the features?
Yeah, I didn't replicate the features out. And I don't know if that's going to give you a huge gain either. And people that understand deep learning well and know how to tweak some of these ensemble models could do pretty well. But yeah, we'll have to, people can always surprise you with what they do. So you just have to wait and see. No, you can do any language you want. A lot of people will be using R.
Should I use OpenC or what does it matter?
It doesn't matter. All that matters is you can export a CSV file. That's a single column because that's what the server is expecting. So, yeah. So I think that's pretty much it.
Thank you.
Anything else?
No, I did want to leave a little bit of time in case people wanted to start talking about teams, approaches that they would want to do, hash things out together, you know. I don't think this is a situation where saying, hey, you know what, I think it's going to lose your competitive advantage, right? So I think talking with each other a little bit, finding a way to be able to collaborate, that's the purpose of the competition we want anyway. So talk, find out, see if there's ways to work together.
So
Thank you,
I'm
Ben.
hoping that we could plan time too, that when phase one is over, at the top 1 or 2 or 3 people walk us through how they do it. Just, I know I would learn from that. I would appreciate that if we could spend some time letting them do that.
Yeah, thank you.
Absolutely. There's an event in July that would work perfectly for that in Sparks. So maybe we'll bring that up and maybe we'll get them to come present, or we'll use one of the user group meetings to do that. We've done that in the past. We've done that at most of the conferences and stuff to show them.
Do keep in mind that our region is the Intermountain region, so we have a lot of people in Colorado that are going to compete and others, and so one, let's please make sure we're all in the top 3, but we might not be. And so it might be really difficult to tell who is the top 3 here. But we could try to pick from the crowd as much as possible.
Yeah. Well, the site has a real-time leaderboard based on the public score. So we've had people get burned in the past for their first, but they ended up overfitting based on feedback. Yeah. So, but it does give you, last time it was pretty spot on. I was only off by like 1 or 2 on the rank. So if you were in the top 3, you were probably in the top 3. And that way you kind of knew where to start. Yeah. So if you're ahead, you know you're demoralizing your competitors and behind.
You just find a diamond.
Yeah.
Ben, is there a way to split those rankings up into the different regions?
Yeah. Yeah.
Maybe we can do it manually later if we need to. If we can, that'd be great.
Yeah, that shouldn't be too bad. And then I had a personal question. Is there anyone out there that's trying to predict stuff right now outside from this, like from work? Like they've got a churn model or they just got a data set at work that they want to predict? No one needs to predict anything.
Yeah.
Make sure you got that.
Oh, yeah? Oh, you got a text model? Okay.
They have a benchmark.
Mm-hmm.
I think I'm building some new features based on
Okay. But no one has anything for work that they're doing? We're in Dave and I were in another competition, Starfest, and we're actually looking for free data sets. So if anyone has data sets that they want to predict, we're interested in predicting.
Well, in that case, I might have one, but I'll tell you about that.
Okay. Yeah, no strings attached. We just need data sets.
That's a September event, right?
It is, but we want it sooner than that. We just want to show that we can offer value to local individuals.
And if you get a chance, go to Starfest and vote for him too.
Yeah.
There's a lot of great things really on Starfest. You should go look at it and vote for, whoever you think is good as well. But there's a ton of great stuff out there. I know I've got a few friends that are doing this and I'm voting at different times. I was going to ask too, you said that you put those libraries in so far, the ones that you guys did. Are those now available?
So that's behind, so for the Startfest competition, we have a web app where those libraries are sitting behind it.
Okay.
And the idea is you can upload any data set,
Right.
text, image, audio, categorical, time series, and then it automatically, so this is actually an output. And we want to offer this for free. And so we figured out that we can run 1 million models per month on the cloud for $9. So
That's a lot.
but the issue we have is how do you communicate results to local individuals that they may not understand these plots.
Yeah.
And there may be no value for them in these plots. So we want to, that's kind of what the touch points we need. You need to find local companies, local problems that you want predicted, and you have an action coming out of that. And we want to see if we can fit that within the scope of what we're trying to do. But yeah, just, you can tweet at me, message me on LinkedIn. But, okay.
Thanks, man. We'll stay up. I'm going to stop the broadcast.